Hello, this is Deborah Barrett with the Cincinnati State Physics Department, reviewing important details from Physics 1. My screen is showing page 3 from the Physics 2 information packet. As you see, this page is entitled Essential Background for Physics 2. I'm not going to review everything on here. Much of it is self-explanatory. But there are some elements that would be good for us to go over. In class, we've already talked about Newton's first law of motion. Newton's first law says that an object maintains constant velocity, maybe zero velocity, if any outside forces on it are balanced, or if there are no outside forces on it at all. Newton's second law of motion describes what happens when the forces acting on an object are not balanced. Newton's second law, as we reviewed in class, says that acceleration of the object will equal the net force on the object divided by the mass of the object. The next entry I want to remind you of is the mass-weight relationship. The mass-weight relationship gives the formula between these two items. That formula is that the weight of an object will equal its mass times the acceleration due to gravity You remember that the acceleration due to gravity is commonly known as g, so that the weight, which we often designate as the force due to gravity, F subscript g, can be presented force due to gravity equals the weight, equals the mass times g. In order to help you with these calculations, I have a chart that I'm going to fill out here. As you can see, I have a column with 3 systems of units. The MKS system is the big metric system. This is also known as SI, which stands for System International, and loosely we often refer to it as the big metric system. The CGS stands for centimeter gram second, so that's the small metric system. CGS is usually not capitalized, unlike MKS, which is capitalized because it refers to meter kilogram second, and those are big units. The third system we'll look at today is the USCS. That stands for the United States Customary System, often referred to loosely as the English or British system. In the first of these systems of units, the mass is measured in kilograms, and G in that system would also be in big metric units, so that's 9.8 meters per second squared. The unit for weight in the big metric system is the same as the unit for any other force in the big metric system. That's the Newton, which is symbolized as capital N, and which is equal to a kilogram times a meter per second squared. In the CGS system, the small metric system, the standard unit of mass is the gram. The acceleration due to gravity is 980 centimeter per second squared. And the unit for weight, like for any other force, is the dyne. I don't think there's an official symbol for the dyne, but here at Cincy State we often use dN as the symbol for the dyne. The dyne is defined as the gram times the centimeter per second squared. Then, for the United States Customary System, the USCS, the mass unit, you may recall, is the slug, which is symbolized as lowercase sl. The acceleration due to gravity is 32 feet per second squared, and the unit for force, including weight, is the pound, which you remember is symbolized lb, and is equal to a slug foot per second squared. In each case, this definition of force specifically means the amount of force that is needed to cause one of these mass units to change its velocity or accelerate at the rate of one of the acceleration units. For example, a pound is the amount of force needed to make one slug accelerate at a rate of 1 foot per second squared. Or a newton is equal to the force that is needed to make 1 kilogram accelerate at the rate of 1 meter per second squared. I'm going to present a second video showing a sample calculation of mass weight. Meanwhile, going back to the essential background page, we've just talked about the mass-weight relationship. The next one that I want to just highlight for you is the friction concept, equation, and problem solving. You want to keep in mind that friction is a force that opposes motion based on the clinginess of the surfaces that are in contact. The relationship for friction is that the friction force can be found, roughly speaking at least, by taking the coefficient of friction multiplied by the normal force between the two surfaces that are in contact. So we have coefficient of friction times normal force. This is probably a good time to remind you of what normal force means. Normal force means the support force acting perpendicular to the surface that's providing the support. The normal force is not necessarily the same as the weight. There are many situations where the normal force is equal to the weight, but there are many situations where the normal force is not equal to the weight. If you're puzzled by the thought that the normal force might not equal the weight, please ask about that in class or in office hours. Meanwhile, do not assume that the normal force is the same as the weight. There is a table of coefficients of friction in your textbook in Chapter 4, so that you can look those up when needed. You'll want to keep that in mind. We have separate videos looking at the kinematics equations that you can review. We also have separate videos already posted looking at work, power, energy, and the law of conservation of energy. So I will not review those in this video. There will be another video showing a quick sample calculation using the mass-weight relationship, for which we just made up a chart. And this set of videos that I've mentioned will complete our review of important concepts and strategies from Physics 1. Thank you for joining me for reviewing Physics 1.